47A. Okay, I don't have 47 on here, so can you? No, we definitely can't do all of them. What is what does 47 say? Is it the theater one? Oh, okay, the cans. Do we need to do 46 before we do 47? Yes? Yeah. Okay. Heaven forbid you guys would ever do a word problem all by yourself. All right, 46 says you have a theater, and it has what? 20 rows of seats. Each successive row goes up by 3. And how many seats are in the first row? 18. Okay, so A says what? Okay, write an arithmetic series to represent the number of seats in the theater. So the first row has 18 plus. The second row would have 21 plus 24 plus 27, and we would go on to do that for 20 numbers, right? And I don't want to do that, okay? Okay, what does B say? Okay, so now we are going to find the sum of all of those things. And so in order to do that, we need to know the first term, we need to know the last term, and we need to know the number of terms that we are dealing with. What's the first term? 18. What's the last term? Don't know. How many terms are we dealing with? 20, because there are 20 rows. Okay, how do we find the last term in the series? What? Right, we use the other equation. Jordan, can you tell us what that other equation would be? Plus n minus 1 times, times 3, because that's the common difference. Okay? So what do I plug in there for a sub n? What am I trying to find? Oh, no, we do know already that there are 20 rows, so yeah, I'm going to plug in 20 for n, right? And then figure out what this is. Okay, so I'm going to take 18 plus 20 minus 1 times 3. So that's 18 plus 19 times 3. So that's 18 plus 57, so that is 75. So the last row in the theater has 75 seats. Some people, fourth period, I don't know if anybody did this period, just wrote out all 20 thingies till they got to, okay, till they got to the last one and they came up with 75. Yeah. Right, I know, C is bad. We're not done with B yet. We need to know how many seats there are in the theater. No, that's how many there are in the last row. There's 18 in the first one, then 21, then 24, then 27, then... Right, so now we have to do this other formula, this Sn thingy. So what is that formula? N over 2, so 20 over 2. What? Yeah, first plus last, and so the first one is 18, and the last one is 75. So 18 plus 75 is 93 times 10 is 930 seats altogether. Yeah. Oh, sure. Hi, Emily. The Sn formula is n over 2 times a1 plus an. Oh, in the parentheses first and then multiply by n divided by 2. Okay? Okay, so there's 930 seats total in the place. You guys think that's big? I've played in venues bigger than that. My band's not even very good. What does C say? Okay. So rows 1 through 5 is $60 each. And then 6 through 10 is $55 each. And then 11 through 15 is $50 each. And then rows 16 through 20 is $45 each. We were trying to think of a short way to do this fourth period, and we really couldn't come up with one. Did you come up with one besides just breaking it into the... Okay. Okay. So did you just hit it with a sledgehammer and just write out all 5 of the things? And all right. So I don't know. It seems like there should be an easier way, but I couldn't come up with one. So $60 for the seats in the first 5 rows. How many seats are there in the first row? 18. How many in the next row? And then 30. So you would do that whole thing. And then 55 times 33 plus 36 plus 39 plus 42 plus 45. Good news is you guys don't have to do all this because Connor did it for us. Okay. Uh-oh. Okay, so it seems like there should be an easier way, and I mean, I guess we could use a little, a summation thingy to figure out that, yeah. But that doesn't seem like it'd be that much faster. Okay. All right. Yeah, it's just whatever. So you add all those up, and let me do that math in my head just real quickly. Let's see, 5 times that, carry the 7, multiply by the square root of the sunset equals 46,950. When you said you had some cents in there, Kelsey, I didn't like that because you're multiplying by whole numbers the whole time, so you shouldn't end up with any pennies. So there's something there. Huh? Oh, yeah. The people in Kazakhstan. All right, and then you want 47? Okay, so we did 47 wrong fourth period, so there's a second chance always. Fourth period. Yeah. Anybody ever see the movie The Jerk? Yeah. Steve Martin, The Jerk? No? All right. Okay, 47. A supermarket displays cans in a triangle. Good for them. Write an explicit formula for the sequence of the number of cans. And so the sequence of the number of cans is the first number of cans is 2 plus how much in the next row? Right, how much in the next row? 3 plus 4 plus da 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 da. And so what Jordan is saying is in the first row you got 2 cans, the second row you've got 3 cans, third row you've got 4 cans. So the sequence is n plus, or the explicit formula is n plus 1. Okay? Nice job, Jordan. B, use summation notation. Well, we're going to learn that today, so you can skip that. C, suppose the triangle had 17 rows. How many cans would be in the 17th row? Well, if we use Jordan's handy dandy little formula, n equals 17. So how many cans we got? 18. So in the 17th row there would be 18 cans. And then finally, D. Oh yeah, okay. Could the triangle have 110 cans or 140 cans? Explain. So what they're asking is, could this summation thing ever equal those things? Okay? So we have to come up with a formula for the summation dealio for this. So this is going to be a little bit tricky, but we got it. How many terms are there? We don't know. Okay, so I'm going to leave that as n divided by 2. What is the first term? 2, right? Yeah, I don't know why they didn't start with 1. They got 2 cans on the top. Plus, here's a tricky one. What's the last row? What? No, it could go on forever. They could like build a tower to the sky, so we don't know. But we have a formula for it. It's n plus 1. Okay? So the sum of the cans is going to be n over 2 times n plus 3. So for example, if you wanted to know how many cans were in the first row, if you plug in 1, 1 plus 3 is 4, times a half is 2. If you want to know the total number of cans in the first 2 rows, you would plug in 2. 2 divided by 2 is 1. 2 plus 3 is 5, and then you would have 5. Okay, so that's going to tell you how many cans you have all the way through. Yeah? Uh-huh. Huh? Yeah, we're going to have n squared because if you do the individual sums, which the problem is not asking for, but that's what I thought it was asking for, fourth period, so I did this incorrectly. The first sum is 2, right? Then this one is 5, and then if you add the first 3 up, you get, no sir, 9, and so you're saying, oh, this is up 3, and then this is up 4, and then sure enough, the next one is up 5, which means that this would have 14. So the first differences are not the same, but the second differences are, which is your clue that it's going to be a quadratic. Nicely done. So that's not answering the question. The question is, can there be 110 cans? So let's set this equal to 110 and solve for n and see what happens. Okay? What's that? Not divide by 2 because it's already divided by 2. I've got to do the opposite. I've got to times by 2. So it's going to be n times n plus 3 equals 220. Okay? Then what? Divide by 3. You are crazy, girl. Get on out of here. What? No, because it's in the parentheses. Kelsey? Distribute. Yeah, so n times n is n squared plus 3n equals 220. Okay. Oh, yes. Now what? Subtract 220. Never. Okay. So in order to solve this, what would we need to be able to do? We'd have to be able to factor it. Okay. So I'm looking for two numbers that multiply together to be negative 220 and add together to be 3. Okay. Sure, let's quadratic formula it. Nice idea. So if I do that, then A is what? 1. B is 3 or negative 3? I can't remember. 3. And C is negative 220. So if we quadratic formula it, we get 13.4 and negative 16.4 as our answers. So with that in mind, can you make a pyramid of the cans with that? No, because these come out to be decimals, and we can't have decimal rows. Okay? So this answer turns out to be nope, not going to work. And we would have found that there's no two numbers that multiply together to be negative, no whole numbers that multiply together to be negative 220 and add together to be 3. Right, you would skip over that number of cans. That's exactly right. It is kind of weird. Right, but right. Well, you're not adding 1 each time. You're adding 3 and then 4 and then 5 and then 6. So you're adding more and more each time. So if you're adding 1 each time, then of course you would get to 2 or 110. You'd get to all the numbers. But for this one, you don't because you're skipping over things. And it'd probably fall before that anyway. Unless they're like really big wide cans, like paint cans or something. Those are pretty easy to stack. Cans of corn, I don't know, tricky. You're going to be really hard is those Pringles, the stacks or whatever they are. Like, because those are those plastic thingies and they're, oh boy, that would be rough. Okay? Right. Oops. Okay, and then we're supposed to do the same thing with a different number, but I don't want to, so we are not. Any other questions from your assignment? Nope, we're good? Okay, will you pass those forward, please? So the first thing to understand is that we're using this crazy letter right here, okay? That bothers students right away. Okay, it makes you, many kids, emotionally uncomfortable because why would you be using like an E shape to add things up? And so my explanation for that is the Greek letter sigma. And so it's actually the Greek letter S. And since the word sum starts with S, if you're Greek, it makes a lot of sense, okay? So if you're in Greece and you're watching this video, just understand that those of us in the United States are confused by this because why would you use an E to stand for adding things up? We don't understand your alphabet, okay? But we're working on it. We're trying to bridge the gap, okay? One world, one love. All right, so when you see that E, don't think E, think S, think sigma, all right? Nope, you got to put that, all right? Okay, this little guy then gets 3 different things to go with it. The number down here is the number that you want to, it's the number term that you want to start with, okay? Now in this example they're being weird and they're starting with n equals 3. Why would you ever start a series with the 3rd term, okay? You can, but we're not going to. So usually this is going to be n equals 1. That tells you what number to plug in first, okay? Then there's a number on top, and that tells you what number to plug in last. So how far do you want to go? And how far is that? I'm at 10. Okay, thank you. That's the other thing that's crazy about this example is they start with n equals 3. They go to 108. Are you kidding me? How many things you have to write out? We don't want to do that at all. All right? Okay, and then this tells you the formula that you're going to plug the numbers into to get your series. So what would you like that to be? N plus 1. Beautiful. All right, so if I see this, what that means is I would like to add up the first 10 terms of the series defined by the formula n plus 1. Okay? What will the first term of that series be? 2, because I'm going to start with n equals 1. So if I plug 1 into there, 1 plus 1 is 2. Okay? Plus, what is the second term of that series going to be? 3. What is the third term? 4. And then 5, and then 6, and then 7, and then 8, and then 9, and then 10, and then 11. Okay? And I stopped at 11 because we said let's go to 10. And when I plug 10 into here, 10 plus 1 equals 11, so that's how I know that I'm done. Okay? So that's what this crazy stuff here means. This is where we start, this is where we finish, and this is the formula that we use to get the actual numbers of the thing. Okay? The confusing thing 4th period was people wanted to say, well, I thought you meant the first term was 1 and the last term was 10. That's not true. We're just starting with n equals 1 and ending when n equals 10. Okay? Does that kind of make sense? Okay, so let's take a look at an example. So let's say that I had the series 7 plus 11 plus 15 plus blah, 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 plus 203 plus 207. Which one of these crazy things would represent that series? Huh? Not at all. How's that? There? There. Okay. So how do you figure that out? Yep, we got a couple terms. Uh-huh. Okay, what? Say it again. Goes up by 4 each time, yes. And what Jordan has just discovered is a very important thing. The amount that it goes up by each time is the number in front of the n right here. Okay, so we can now eliminate this, and you can eliminate this. And you should be able to see that because if I plug 1 in here, I get 7, which is a good start. But then what do you get when you plug in 2? 14. And the next term in our series is 11, not 14. So those are not going to work. Okay? So then the last question that you have to answer is this term right here, the last one, is it the 51st term or is it the 50th term? How do you figure that out? Yeah, plug it in. So which one, make a guess, 51 or 50? 51. Okay, so if I take 51 and plug it into here, 51 times 4 is 204 plus 3 is, ta-da, 207. So it must be this guy right here. Okay, so you see the connection between those things? This number gives you the first term, this number gives you the last term, and this tells you the formula for generating all of them. Yep, that's what you start with. And that's almost always going to be n equals 1. What's that? The not always part is when you will see this again next, which is when you are taking calculus. And then these numbers actually represent something on a graph, and then we'll just move it around so we won't always start at 1. Okay? But for now, 1 is going to do the trick. Jordan? How do they know it's plus 3? Oh, okay, good question. So if I'm going up by 4 like this, let's say I go backwards. You made me blow that up, but what would be the term in front of the 7? Ta-da! Okay, so this is the difference, and this is not the first term, it's the 0th term. Okay, it's the term before the first one that they give you. Okay, does that kind of make sense? What's that? Yeah, there is a negative first term. Yeah, right. What? Right, it's the one before the first term, so it's the 0th term. Okay? Okay, so now let's go the other way, and this is a little bit harder. And the last thing that we're going to do is actually easier than this. But let's come up with a formula for these two things. And it's going to be all about what Jordan just told us. Okay? What are these going up by each time? 7, so it's going to be 7n. Okay, what would be this term right here? Minus 12, right? Because if instead of adding 7, I subtract 7, then I would be at minus 12. Does that make sense? Okay, then we're going to start at 1. And then the last thing I have to figure out is how many will it take me to get to 268? That's the only tricky part. How can I use this to... You could. I could keep plugging in numbers, multiplying them by 7 and subtracting 12 until I found that as an answer. But as a math teacher, I tend to sort of shy away from the guess and check and sort of go with the algebra instead. Okay? So if I take this formula that we came up with and set it equal to the last term, when I solve that for n, that tells me how many I have. Okay? So what are the two steps to solve that for n? Add 12, so 7n equals 280, and then divide by 7, so n equals 40. So the formula for that is 7n minus 12. The 7 because we're going up by 7 each time. The minus 12 because that would be the term before what we started at. That's essentially the y-intercept when x equals 0. And then this is the 40th term of the sequence. Yes, sir? Well, like I said, you could actually, I mean, this would blow everybody's mind, but we could change this into n equals 3, and we could adjust this formula so that if I plugged 3 into there, I would get negative 5 as an answer instead of when I plug in 1. And then it would, instead of going from 1 to 40, it would go from 1 to 42. I mean, from 3 to 42, but why would we do that? Okay? The thing that we're getting at, just give you the little, okay? Eventually, some of you, hopefully, 2 years from now, will be sitting in this same room on maybe not as hot a day as this. And in calculus, you say, here is a curve, all right? Let's find the area underneath that curve from -2 to 5, okay? Well, the first thing that happens is you go, oh my gosh, how do I find an area underneath a curve? It's curved. How do we do that? Well, essentially what you're doing is you're taking a bunch of rectangles and adding them up. And then, yeah, and the fun part is, you know how many rectangles we add up? An infinite number of them. So calculus is really easy to teach because I just come in on day 1 and say, okay, add up an infinite number of rectangles from -2 to 5, and then the year ends and you're still not done with that one problem because you're trying to get to infinity. And the whole time on, no. That's where the calculus comes in. How do you actually add up to infinity? And so that would be a situation where instead of going from 1 to 40, we would be going from -2 to 5. Does that kind of give you a little window into the future? What this formula would give me in this case then would be the heights of the rectangles instead of and so that's what we'd be. Okay, so that's kind of, all right? Okay, but that's for further down the road. Okay, how about B? Now that we know all the secrets, it's a super easy process. How much is that going down by each time? 10, so it's going to be -10n. What is the term before the one that they gave us? 510, so it's going to be -10n plus 510. I'm going to start at n equals 1 because that's just how I roll. You could change it to be a different one if you want. And then I have to figure out which term is this in the series. How do I do that? Set it equal to this guy right here, so -10n plus 510 equals 10. So -10n equals -500, so n equals 50. Okay? Yeah? All right, the fun thing is going the other way, because if you are starting with this notation and you are asked to add them all up, then it basically tells you everything you need to know right off the bat to use that formula that we learned yesterday. Remember, you need to know the first term, you need to know the last term, and you need to know the number of terms. Okay? So what's the first term in this case? Nope. 8. Because if I plug in 1, 5 times 1 is 5, plus 3 is 8. So the first term is 8. What's the last term? I have to plug in 70. Okay, so 353. How many terms are there? 70. Is what an n? That's an n, that's an n, that's an n, that's an n. That's an n, that's an n, that's an n, that's an n. Okay, so a lot of n's, yeah. Okay, so do you see how easy that is to figure that out? Because you can just use this information and it gives you all the pieces that you need right off the bat. Yeah, so it is going to be a pretty big answer. So the sum of these 70 terms is n divided by 2, 70 divided by 2 times, because we're pairing up the first number and the last number, and then the second number and the second to the last number, and da-da-da-da-da. And so there's half as many pairs as there are total number. Okay? So 70 divided by 2 times 8 plus 353, which is 35 times, what was it, 361? So 12,635. So this is easy peasy, okay? This one? The 70 is the number of terms, and that comes from this number right here, okay? Yep. Yep. Evan? Uh-huh. That's what we were talking about where Jordan said the common difference is the... Oh, keep going back. Oh, okay. There's a lot of n's on that page, too. Is that what you're looking for? You good? All right. Okay, the only last thing that we're going to talk about today is that you may not always just assume that everything that you're working with is an arithmetic series, okay? So for example, as soon as you throw like a squared in there, then that fun little formula we have for adding them up will not work anymore. So this is asking us to add up the first 7 terms of the series of n minus 1 squared. It's only 7 terms, so we're just going to list out the 7 terms and then just add them up by hand, okay? So what would the first term of this series be? What? 0, because 1 minus 1 is 0, squared is 0, plus. The second term is 1, because 2 minus 1 is 1, squared is 1. The third term is 4. The fourth term is 9. The fifth term is 16. The sixth term is 25. And the seventh term is 36. And that gives us 1, 2, 3, 4, 5, 6, 7 terms. So can you see from the ones that we generated that this is not an arithmetic sequence, so we can't use that little formula. So we're just going to add it up. We're going to go 61, 81, 91, and call it good. Okay? So be careful with that. Don't always assume that you can just use that formula. All right? Yes? Yeah? All right. Okay, so here's what we're going to do. For the kids who are gone, as a little incentive for them to watch the video, we are now going to make up the magic word, the word of the day. And if any of those kids actually watch that video and they hear this word and they come in and tell me that word, then they get extra credit, okay? But if nobody does, then all of you guys get extra credit instead, all right? Okay, so don't tell them, all right? So today's magic word is refrigerator. Okay? Shh.